So the hardest part about making your own neurotech app is the combination of advanced machine learning and having to make a software architecture allowing for real-time analysis. And that makes it really, really hard and really daunting to make your own neurotech app. So we decided to change that with Neurostack, which is an open source EEG cloud service.
Hi, my name is Cyan.
This is Jeremy.
Steppa.
Jen. Yangling.
Nick.
Carl.
Ibrahim.
So Neurostack comes with two parts, the Neurostack client and the Neurostack cloud. The Neurostack client accepts Muse data via Muse LSL and markers via socket IO from whatever front end you have. It then epochs the data for you and sends this data to the Neurostack cloud, which can then predict whatever event-related potential or any other neurological marker you are trying to find. It'll send this data back to you via socket IO, which you can then use in your app.
What the marker data is it's basically a timestamp for which we want to either make predictions for, or we want to use to train our classifiers. Right, so it grabs the marker data and it grabs the EEG data and then it puts it together into what we call the ML stream, which is basically we're going to the marker timestamp and we're taking the section of the EEG data that we're concerned with, and then we're only using that section of EEG data. We also do a bit of pre-processing on this data, such as running a low bandpass filter and only taking 100 to 750 milliseconds after the marker, since that's the only time period that we're concerned with. After this, we send the data to the P300 server, and then the P300 server does its training, does its classification and predictions, and it sends the data back through the client to the front end. But we took the server and then we basically deployed it onto Google Cloud Platform so that all of the machine learning, all the classification stuff can be done in real time by sending jobs to the cloud and then getting responses back. So currently we have the P300 service, but we also have the NLP service, which is some basic natural language processing done with an Ngrams model. It also contains emoji prediction, and that is done with TorchMoji.
So we wanted to test this idea by doing a full rewrite of our MindType mind-controlled keyboard. So this mind-controlled keyboard uses P300, or the oddball paradigm, to infer what letter you are trying to type using a series of flashes. We are using, in the new iteration, React plus Electron for the front end. We are using Neurostack to do the EEG analysis, and to actually make the keyboard type as if it was a real keyboard, we are using Robot.js. This whole refactor allowed us to completely rethink the user experience of MindType as well, and see what opportunities going to the cloud can help us with.
How the classifier works is that we take all of the channels, all 4 of the channels that we get from the Muse headband, we train those together to a target. So we're treating all 4 channels and all of the samples of data as one object, and we're training that to either P300 or no P300. The actual pipeline, we took inspiration from Alexander Bereshance's work. So we tried the vectorizer plus logistic regression pipeline, and also the ERP covariances and MDM from Pyreman, which Alexander Bereshant made. So between these, we had similar accuracies. We got between 60 and 70% on both of these. In theory, the ERP covariances should work better, but I think that's more of because our data might have been a little bit faulty.
The UX and UI team have been working to design an intuitive and easy layout for the MindType keyboard. Designing for the MindType keyboard was an interesting and challenging endeavor. The keyboard is already so established and standardized, but because we're interacting with the keyboard with our mind and not our hands, we decided we need to take a whole different approach. We considered classic QWERTY keyboards, square layouts, different colors, different flashing speeds, to figure out what worked best. We storyboarded the user experience, and then we made lo-fi prototypes, which we tested on before we made our full prototype in Adobe XD. One thing we realized that even if designs made perfect sense to us, it was not easy to predict how the user was going to understand them. And so to remedy this, we decided to come up with a tutorial walkthrough that walks the user through the typing process, starting with a simple 2x2 mini keyboard up until the full keyboard, including predictive text and emojis in different modes. We wanted the instruction screens to have a twofold purpose. So not only to teach the user how to use the keyboard, but also to send data to the machine learning team to better calibrate the keyboard to the individual user. Here we ran into the problem of collaborating with the machine learning team because we realized they had specific needs on how many data points and flashes we need to send them in order to properly calibrate. Similarly, we also had challenges communicating with the front-end team to make sure they actually understood our designs and knew how to properly execute them. For the future, we definitely plan on doing more usability tests in order to create a better next iteration, as well as exploring the possibility of a mind-controlled mouse or mind-controlled arrow keys to better navigate the computer hands-off.
Hi, I'm Yan-Ling and I'm on the front-end team. We wanted the MindType keyboard to be able to type into any application on your computer. To accomplish this, we decided to use Robot.js, a Node.js desktop automation library that can control the computer's mouse and keyboard. How it works is that when a letter is found, the React app uses Socket.io to emit an event. The robot server listens for this event and then types out the corresponding letter.
Since reusability was critical to the success of MindType, one of my biggest challenges was writing the instruction screens in such a way that facilitates reusability and to break down the different components into smaller parts. However, I realized later on that because the different parts of the instruction screen components were often very different in their layout and their functionality, I ended up realizing that reusability was not always feasible, and so often I had to refactor the code. Perhaps an even bigger challenge that I faced was to implement the flashing algorithms across the different instruction screens. It was quite challenging because often the keyboards on the instruction screens were different in their layouts. The actual buttons were different in their layouts than the actual MindType keyboard. So the flashing algorithm had to require some tweaking to work on the instruction screens.
So we were expecting when doing Neurostack that lag would be an issue because you're doing a lot of analysis on the cloud and there's data in transit. We actually found that lag wasn't too much of an issue. And the reason why, for MindType at least, is that you have a buffer region of about half a second. And so if you make sure to sync up your timestamps properly, you can afford that time for the analysis to happen and for the data to come back.
There is a huge error in which we were training each channel individually instead of all 4 channels at once. And since the channels were unique, that created a lot of errors. And one of the big things that we're still working on right now is the data collection. So we tried collecting the data in a controlled environment where it was quiet and in which I can concentrate in, but the data was still suboptimal compared to Bereshant's. I think to remedy this, we either have to fix more conditions or we have to collect a lot more data, since we only had, I believe, 4 or 5 minutes of data in total, and a lot more data would mean a better average.
So one of the hardest things about trying to make the P300 service was, for its training, we had to have a very good experimentation setup. Now, if you don't have a good system of oddball experimentation, you're not going to get the best data because the person could be diverting their attention to other things. And so we try to tackle that by having very close integration between the machine learning teams and the UX team and the front-end team. So I'm actually really excited for the future of Neurostack, as that's going to be the cornerstone of all NeurotechUofT innovation. So far we have P300, but we want to move on to visually evoked potentials, audio evoked potentials, and then even motor imagery. One of the things that I'm really excited about is doing Imagine hand gestures with 9 different hand gestures. That is something that we tried to do for our last iteration of MindType, but we want to bring this to the cloud and test it on the mother of all BCI benchmarks from NeuroTechX to see what are the limits that we can hit in terms of EEG cloud computing. The next step for battle testing P300 is to completely polish the training stage of MindType, as that will allow for better experimentation for the oddball paradigm, and that will really let us see what sort of benchmarks and what are the highest accuracies that the P300 service can output for a P300 prediction.
I'm currently a student in high school, and I joined MindType last year with little prior programming experience. There was definitely a steep learning curve as everything was new to me. I didn't know how to install libraries using the command line, and I definitely didn't know anything about Robot.js, React, or Electron. It was challenging for me because I was simultaneously learning and doing, and I ran into a lot of errors along the way. However, through working on MindType and with the support and guidance from other members of NeurotechUofT, I've gained more exposure to the field of neuroscience, different libraries and frameworks, and I got used to using GitHub, Asana, and a lot of Stack Overflow. It's been super cool for me to go from not knowing anything about P300 to seeing some of my code used in the final project. I definitely gained a lot of confidence through this experience and a lot of insight into what it's like to work on a technical project with a team.